For today's lesson, we are looking at probability, specifically new content today will be conditional probability. So probability is what we use to determine the likelihood that something will happen. It's usually expressed as a fraction or as a decimal or percent. Fraction or percent are probably the most common. That fraction would be somewhere between 0 and 1, with 0 being a impossible chance that the event occurs, 1 being a guarantee that the event occurs. So by definition, probability is a ratio that measures the chances of an event occurring. So it's expressed as that fraction there, 2/3 or 2 out of 3. We could make that a decimal, 0.6 repeating. We might round that to 67%. Other vocabulary, sample size, number of trials performed, where you get your data from, and then finally conditional probability. That is the new part for today. Conditional probability is the probability of an event given another event has already occurred or is already determined. So this part right here, this word given, is what makes it conditional probability. As we work through some of our examples, we're actually going to see that word given, and that is our clue then that it is conditional probability. So looking at example 1 here, looking at the probability of these 4 different events occurring. As we are looking at probability, this one, a die is rolled, a 6-sided number cube is rolled, right? There may be times where it's useful to list out your possible incomes, right? What can happen if I roll a die? Well, I can get a 1, a 2, a 3, a 4, a 5, or a 6. Those are my only options, right? So for a 6-sided die, listing out this outcomes chart or table, not super necessary. As we get into some more complex problems, it will become more necessary. So the first question, what is the probability that a 2 is rolled? Well, I see here there's only 1 2 on my die, and there are 6 total options that could happen every time I roll. So there is a 1 in 6 chance that I roll a 2. I could type that fraction into my calculator, 1 divided by 6. I get that repeater. I could round it off however is necessary based on your situation, 16.7%. You could round it up to 17%. It just depends on how accurate you need to be in your situation. Part B, what is the probability that an even number is rolled? Well, 2, 4, and 6 are my even numbers, so I have a 3 in 6 chance or a 1 in 2 chance of rolling that even number, right? Equivalent fractions there, 50% chance. Rolling a number bigger than 2, I can draw a cutoff there, right? I have 4 outcomes that qualify as bigger than 2. 4 out of 6 chance to 2/3 chance. I could round that to something then equivalent, 67%. And then D, what is the probability that I roll a 7? Well, 7 is not an outcome, right? So 0 out of 7, a 0% chance. It is not possible. It is impossible for that to happen based on my die, my number cube. Another place where probability gets used a lot is drawing something out of a bag or a hat or whatever. So we have 8 blue marbles, 10 yellow marbles, 6 white marbles, and 6 red marbles. What is the probability? You pick one at random. What is the probability, for example, A then, to find a red marble, right? So number in favor, there are 6 reds, right? That's what we're looking for here, 6 reds. And then if I add up all the marbles, that would be 30. So I have a 6 out of 30 chance to roll or to pull a red marble out of the bag. I could type that in, then 6 divided by 30, right? 0.2. So that would be a 20%. I'm not going to go through all of these. on the calculator of dividing them out, right? It's just numerator divided by denominator, and then scooting that decimal over 2 places to turn it into a percent. So blue marble, probability I pick a blue marble, well, there's 8 blues, still 30 in the bag, right? If I round that to the nearest whole number, 27% chance. 10 yellow marbles, right? 10 yellow marbles, still 30 in the bag. So that's a 1 in 3 chance, a 33% chance. And then what is the chance I pull out a green marble? Well, it doesn't even talk about green marbles. So there are no green marbles in that bag of 30 marbles, right? So not a possibility. The next few examples here have this word given, right? They all have the word given. So this becomes conditional probability down here. So this is conditional down here. And all that simply means is something else has already happened. So, for example, E, what is the probability that a blue marble is picked given that it is not red? So essentially, someone has gone through the bag of 30 marbles and they've picked out these 6 reds, right? So now I only have 24 marbles because the red ones are gone, right? So 8 out of 24. There's 8 blue marbles in the bag out of 24. So that'd be a 1 in 3 or 33%. So F is the same concept. There's no reds. So 30 minus the 6 reds, 24 marbles in the bag. And they want to know the probability of picking one of the 10 yellows. So that would be 42% chance. 10 out of 24 be 42% chance. And then G, picking a white marble, 6 white marbles, given it is not red, so the 6 reds are removed. So that would be a 25% chance, 1 out of 4 chance. And then for H, we're changing it up a little bit. Blue marble is picked given that it is not red or white. So now the 6 red and 6 white marbles have been removed. So there are only 18 marbles. The blue and yellows are left. So 8 out of 18 chance of you pulling out a blue marble there. And then a yellow marble, 10 out of not red or blue. So we are taking out 14 of the marbles from the bag. So that'd be a 63% chance, right? 10 out of 16. Because in example I there, it's no reds or blues. So that's kind of our first look at conditional probability, right? We are given some additional piece of information. Something has been removed from the bag of marbles or whatever it may be. So for example 3, we have data presented to us in what is called a two-way table. Right, so we see that our data is sorted in 2 different ways. We see male versus female, and then we also see if the students are in a club or not in a club. With a two-way table and probability, we are going to need some totals. So this particular two-way table does not provide us with the table, so we would just need to add. Right, so for total number of males, we would add the 156 and the 225, right, 381. We would add the females, 419. We also need to add our columns up, right? I need to know how many people are involved in clubs, so I would add the 2 values there. Not involved in a club, right? And then I would also need to either add my column totals or my row totals, either one, to get my total number of students. So in this case, it would be 800. So we had a sample size of 800. 800 students were surveyed. If a student is chosen at randomly, we're finding the probability. So these first 4 are just regular probabilities, right? So what is the probability that the student is a member of a club? Well, there's 468 club members out of the 800. Right, and then if I wanted to, I could make that into a percentage. Student is not a member of a club. So here I'm at the 332 total here, non-club members out of the 800. And then C and D, male or female. 381 males were surveyed out of the 800, 419 females out of the 800. And I'm just pulling those out of my my subtotals there of males, females, club, no club. So starting here in example E, we now again have that word given. So we are into conditional probability. So for example E, student is a member of a club given that he is male. So we are only going to be looking in this row for all of our data for this question, right? So student is a member of a club, 156 male club members out of 381 total males, right? Because the given is he is male. So that is the only row or the only part of the data that we are going to look at then in this case. So looking then at the rest, student is a member of a club given she is female. So now I am only looking in the female row, right? I'm only going to look here, right? So there are 312 female club members out of 419 total females. G, student is male given he is a member of a club. So now I'm looking in this column, 156 male club members out of 468 total club members. Student is female given that she is a member of a club. So the 312 out of 468, right? Everything came out of this this column right here. And then for I and J, student is male given not a member of a club, right? So we are going to be looking here then, not a member of a club. So 225 males not in a club out of 332 total students not in clubs. And then female 107 out of the 332. Right, so that's using a two-way table. Again, sometimes these totals are provided in the table. If they're not, we just use our calculator to add them up. Our last example looks at decks of cards, right? So we have ace through king in each of the four suits, two colors, blacks and reds. These are the face cards down here, obviously with the faces on them down here. And then aces are sometimes the high card or the low card. And in our particular example, it says regular deck of cards, 26 black, 26 red. An ace is going to be just a 1 in this particular case. Face cards are the jack, king, or king, jack, queen. They're telling us what we pick, and we're to find the probability, right? So the card is a king. Well, there's 52 total cards in a deck, 4 kings, right? 1 for each of the 4 suits. A face card, right? I would have that king, queen, jack in all 4 suits, right? So that would be 12 out of 52. C, we're being a little more specific. The card is a red 2. Well, there is a 2 of hearts and a 2 of diamonds that are both red. So 2 of those out of 52 cards. Again, if you needed to, you could find the percentages with your calculator. For example, D, the card is black given that it is a 3. So there are 4 3s in a deck, and 2 of those then would be black. So a 2 out of 4, 1 out of 1 out of 2 or 50% chance. For example, E, the card is a 3 given that it is black, right? So you could always look back, right? The card is a 3 given that it is black. So you would be then basically eliminating the bottom half of the deck here, right? Those would be eliminated. There would be, these would be the 3s. So 2 out of the 26 then would be the probability for E, 2 out of 26. And then F, the card is greater than 7 given that it is not a face card. So again, might be helpful to look back given that it is not a face card, right? So these are my face cards here. So these get eliminated from my list of possibles, right? Because of the given part of that statement there. And then it says the card is greater than 7. Okay, so that would be right through there, like that. So I have 12 cards here out of 40 total cards, right? 12 in this section right here, right? That's my group that I'm looking for out of 40 total cards. So my probability then would be 12 out of 40. 12 out of 40 total cards. Right? And sometimes it's helpful to have that picture. Sometimes we're going to have to work to draw that picture on our own. So that is a review of probability and an introduction to conditional probability. Moving forward, we're going to look at compound probability, stacking events on top of each other, and some more complex probabilities than what we've done today.